Alright, ladies and gentlemen, welcome to Unit 5 test review from Sourcemath, rational, logarithmic, and exponential functions. So, for the first one, it says determine the x, y, domain, range, asymptotes for the rational functions. So, this might seem a little confusing to start off with, but what I'm going to do is I'm going to start you off with a couple of easy tips. For the first part, I can take a look at the denominator right here. It's x minus 3. So I can say right here, I can say that the vertical asymptote is going to be equal to, you set that whole thing equal to 0 at the bottom. So x is going to be equal to 3. Okay, then I can go over to my graph, and at x equals 3, I can make a dotted line. The next thing, I have to take a look if I'm trying to figure out the horizontal asymptote, whether it's bottom heavy, top heavy, or equal heavy. In this case, this is going to be bottom heavy. So that means that y is going to be equal to 0. Then I like to find out my x-intercepts. The x-intercepts, what you need to do is you need to set the top equal to 0, but since 1 is equal to 2, there's actually not going to be any x-intercept. The y-intercept, on the other hand, you set the x value equal to 0. So that means that when x is going to be equal to 0, you place in that value, so I get negative 1/3. Okay, so usually what you can do is you can plot those points there to try to help you figure out what the graph is going to look like. Now, yet again, this is not a calculator section, a little bit difficult to try to draw, but what you can always do is you can still always set up a table, x, y, start to plug in some values and see what you get. Now, at this point, I'm only going to plot the y-intercept, so I'm going to go over to 0, negative 1/3, and I'm just going to take a little bit of a guess, so I'm going to say right there. And I'm also going to put in my horizontal asymptote, y is equal to 0. Since it's kind of difficult to see it with the y-axis as is, I kind of like to make it a little bit of a diagonal so that we know that there is a horizontal asymptote there. Now, with just this point, and there's no other complexities with this, this is almost like a basic rational function, just moved over 3 units. This bottom part of the graph is going to look just like this. Draw just like this and gets really close to the asymptote but never actually touches it. Now, if you're not sure what's happening on the right hand side, what you can do is you can start to plot in points. My vertical asymptote is at x is equal to 3, but if I actually end up choosing 4, I can go up here. So just kind of do this mentally. 1 divided by 4 minus 3, which is going to give you 1. So you're just going to get 1, 1. So I'm going to have a point right there, and I'm going to see that it's going to be the top part of that graph. Okay, so the domain, that's going to be negative infinity, 2, and then it stops at 3. And then from 3 to infinity. The range, on the other hand, even though sometimes that the horizontal asymptote, the graph can actually go through it, it doesn't in this problem. So we're going to have negative infinity to 0, and 0 to infinity. Anything else I'm missing? Domain, range, asymptotes? Nope, and I'm good to go. On to the next one. Now the next problem, we're still going to start off with the vertical asymptotes, but before I begin, I'm going to actually factor the bottom. So the bottom is now going to become x, let's see, x plus 5 and x minus 1. And I don't need to worry too much about the top, right? I can't cancel anything from the top or the bottom. So I'm going to start off with my vertical asymptotes. This time I actually have 2. I get x is equal to negative 5 and x is equal to 1. So place those in there, negative 5, 1, 2, 3, 4, 5. I end up having that vertical line, and also at 1. Okay, horizontal asymptote, since this is still also bottom heavy because this x squared is on the bottom, I'm going to say y is equal to 0 because, yet again, it is bottom heavy. Now moving on from here, notice that the top right here is x plus 4. So if I take a look at the x-intercepts, I'm going to set that equal to 0. So x plus 4 is equal to 0. So x is going to actually be equal to negative 4. So I have an ordered pair, which is negative 4, 0. That's when the y value is going to be equal to 0. For the y-intercept, make all the x values equal to 0. So you actually are left with 4 over negative 5. So it's going to be 0, negative 4 over 5. Another way of thinking about that is negative 0.8. Domain, range, let's not worry about that just yet. Let's start graphing some points. So I know the x-intercept and the y-intercept. I also know that the horizontal asymptote is at y equals 0. Now here's the strange part. The x-intercept is at negative 4, 0. So we actually have a point right there. And then the y-intercept is at 0, -4/5. So it's almost like -1, but not really. It's going to be in that location. Now, if you take a look at this, you see that the horizontal asymptote, I actually have a point on there, and there is no mistake with this, right? We're actually going to end up having this graph that comes through the horizontal asymptote and passes right through it. Okay, so we're going to have kind of like that cubic looking part of the graph actually within the graph, and you can do that. It's okay. It's when you pass the vertical asymptote, that's when you end up having some issues. Now, once you're trying to figure out the left-hand side of the graph, what we can do is we can pick a point that's somewhere before -5 and figure out whether it's going to be positive, so it's in the lower portion of the graph on the left-hand side, or the upper portion of the graph on the on the left-hand side. So what we can do here is, so I'm on plug in, let's say -6, and I go up to the top and I decide, okay, do I want to pick, when I place in -6 into that top part, I end up getting a negative value. When I place it into that quantity, it gives me a negative and a negative right there. So a negative over a negative times a negative, which is still going to give me a negative value. So when I create my graph, I can kind of almost create a rough sketch. Rather than worrying about plugging in values, I'm just more concerned about the curve that's going to be against the asymptotes. That's either going to be in the top section or bottom section, but since we got a negative value, it's going to be in the lower section. Now working on the right hand side, I'm going to pick, let's say, 2. So yet again, I'm on testing the top. That's going to be positive. That's going to be positive, and the third one's going to be positive as well. So it should be creating a curve just like this that goes up against the asymptotes, just like that. Now, once we are figuring out the domain, pretty simple. We match up the vertical asymptotes. So we go -infinity to -5, from -5 to 1, and then 1 to infinity. Now the range is the more difficult part. As we take a look in the center, right, we can see that it actually goes through the horizontal asymptote, as I mentioned earlier. So it's not going to go from -infinity to 0, but it's actually going to go -infinity to infinity. And that ends my problem. Now moving on to the last problem. This one is actually called the whole example, and I'll explain why. So if I factor this, this ends up giving me x minus 2 over x minus 2 x plus 2. Now what's interesting here is that I can cancel these values, but I still can't let go of the fact that there's still going to be a vertical asymptote at x is equal to positive and -2, right? Regardless of if you can cancel these things out, you still can't plug in positive 2. So what that means, there is going to be a hole when x is equal to 2. Now, I'm going to figure out the y value of the hole in a little bit. But just as of right now, what you can do is once you cancel this, you can actually rewrite this as 1 over x plus 2 and graph just this graph. But you need to make sure that you put in a hole at x is equal to 2. Okay, the horizontal asymptote, yet again, all these are going to be bottom heavy, so it's going to be y is equal to 0. The x-intercept, if we ended up placing a 2, if we set the top equal to 0, that would give us x is equal to 2, but what ends up happening is that's actually where our hole is going to be, so there is actually no x-intercept. The y-intercept, on the other hand, is going to be -2 over -4, which is going to give me 1/2. And positive because negative and negative. Okay, so now let's graph this. So my vertical asymptote, yet again, comes down just like this. Comes down just like this. But you wanted to know where the hole is going to be. So the hole is going to be, if you place in a 2 there, right, the hole is going to be actually at x is equal to 2. And that's what I kind of like to do for my vertical line. So I know that when I'm actually drawing this graph, it's going to form a hole somewhere on this line. It's not going to brush up against it like other vertical asymptotes. It's actually going to be a line that goes through it, but once it hits that dotted portion, it's going to create a hole. Now, where do I find this hole? What I do is I take that x value, which is that 2 right here. Okay, and I plug it actually into my reduced version. So it's going to be 1 over 2 plus 2, which gives me 1/4. So that's supposed to be our y value if the hole actually did not exist, right? If the graph just continued going, if it was 1 over x plus 2. But since it does, that's where our hole is going to be. What I'm going to do is add 2. I'm going to place a little opening just at 1/4, just to kind of symbolize that there's going to actually be a hole right at that dotted line. Now if I finish up this graph, yet again, you can start to pick X and Y values. I'm going to just kind of save some time. Graph is going to look like this, and then the graph is going to come down here, hit the hole, and then continue going from here. And there you go. That's what your graph is going to look like. Now, the domain in this problem deals with, we're going to start off with negative infinity to -2, just like the vertical asymptotes, going from -2 to 2, and then 2 to infinity. Now, the tricky problem with this problem is not necessarily the domain, but what's going to be the range. Now, the range for this problem, we're going to start at negative infinity to 0, but after 0, we have to remember that there's an actual y value for the whole. So it goes from 0 to 1/4, okay? And then after 1/4, it goes to infinity, okay? You gotta be very careful that there is no y value where the hole is going to be. Okay, so solving the following rational equations. Check for extraneous solutions. Now, at this point, you want to look for your LCD. You want to try and find out the lowest common denominator for these problems. So, the LCD. Lowest common denominator. So, if I take a look at x minus 1, I also have this x squared minus 1 also. And if you factor out x squared minus 1, that's a difference of squares, so it's going to be x minus 1 and then x plus 1. So the only thing that this portion is missing is x plus 1 and so on and so forth. So what I'm going to do here is I'm going to write down 3x and then put in the thing that I need. So x plus 1 is equal to, since the 12 doesn't need anything because it has the same denominator, is equal to 12, plus, and then 2 needs that x squared minus 1. And if you have that all over the same denominator, you basically can just get rid of it. So let's distribute. We get 3x squared plus 3x is equal to 12 plus 2x squared minus 2. Now after this point, I'm going to combine my terms. I'm going to bring that over. I'm going to combine the -2 and the 12. I get 10. I'm going to subtract that over. So what I'm left with is x squared plus 3x minus 10 is equal to 0. We want to factor two numbers that when you multiply you get -10, but when you add you get positive 3. So I'm guessing that's going to be x plus 5 and then x minus 2. So x is going to be equal to -5 and positive 2. Now before we end, we need to make sure that if we plug these values back into the equation, that they work. So the only really values that don't work in this problem is 1 and -1, and we're actually good with -5 and 2. Alright, so let's work on the last problem. Yet again, let's try and find out our LCD. I can see that we have this x minus 2, x minus 4, and x squared minus 6x plus 8. And if I FOIL both of those two values together, I should get x squared minus 6x plus 8. So my LCD is going to be x minus 4 and x minus 2. Not necessarily in that order. So the bottom one for the first term is going to be x times x minus 4. The second one is going to be 3x times x minus 2. And the right-hand side really does not need to be adjusted at all. So distribute. X squared minus 4x plus 3x squared minus 6x is going to be equal to 32 minus 2x. Now, the tricky part here is making sure that you just combine my terms correctly. So we end up getting 4x squared minus 10x is going to be equal to 32 minus 2x. Bring the 2x over, so I should add 2x, so I get 4x squared minus 8x minus 32 is equal to 0. So after taking a look at this, I could factor it from here, but I also notice the 4, the 8, and the 32. They're all divisible by 4. So I can actually divide out a 4 from everything, so I get x squared minus 2x minus 8 is going to be equal to 0. Factor this out. I get x minus 4, and I get x plus 2. Just double check. Both those numbers give me -8, but when you add them, you get -2. Perfect. So I end up getting x is equal to positive 4 and -2. But remember, check for extraneous solutions. So place them back into my LCD, one of those values. If I place back 4 in there, it should actually give me a 0 for the 3x over x minus 4 term. So that's not going to work. That's actually going to be an extraneous solution, while the -2, on the other hand, will be one of our solutions. Now, if you had positive 2, that also wouldn't work, but the -2 is okay. Okay, thank you for watching the first page of my review for Unit 5. If you have any questions, please make a comment down below, or please comment on Sourcemath, and have a good day.